questions that I found in one of the Olympiads that we attended, in which they were saying, given that 3 to the power m minus 2 to the power m is equals to 65, find the value of m. So working with such a question is a bit difficult when it's like this. So I try to think what can I do so that I can try to make my life easier solving this equation. So what if I square both sides, but the way I square, it's not going to affect, not both sides as such, but what if I square here so that it won't affect the 65? How am I going to square it? Perhaps I'm going to apply what we call a false one. Let me apply what we call a false one. By multiplying a false one, I mean here we are going to have 3 to the power m bracket all raised to the power 2 over 2. Remember, my intention here is to square, but I want to square in such a way that I don't affect the 65. Then minus 2 to the power m, again bracket 2 over 2 is equal to 65. Is it? So according to the laws of indices, there is a law which says if we have a to the power m bracket o to the power n, this is the same as saying a to the power m, and this is the same as this. So what am I going to do there? I'm going to take this denominator back into this and have 3 to the power m over 2 all raised to the power 2. The same minus 2 to the power m over 2 all raised to the power 2 is equals to 65. I still have my special one, but it's only that I took the denominator inside the bracket. But again, in line with my laws of indices. So now when I have something like this, what can I do? I can replace these terms with letters and say let x is equals to 3 to the power m over 2 and y is equals to 2 to the power m over 2. Meaning that I'm going to have x squared minus y squared is equals to 65. X squared minus y squared is equals to 65. Remember, I'm just replacing this with my letters here. So when we have something like this is completing the square. This is a difference of two squares, I mean, in which if we are solving this, we just say x plus y bracket x minus y is equals to 65. So what can I do? I can make a 65 a product of its prime factors, because here we have a product. So let's also make a product here on my right hand side, but the product should be in such a way that it is in terms of its prime factors. So we are going to have x plus y, x minus y is equals to 65 can be written as 13 multiplied by 5. So in mathematics, once we have something like this, then it means we can compare this bracket to what we have here. But obviously, since we have x plus y here, it automatically means that x plus y is going to be more than x minus y. It's going to be bigger or greater than x minus y, meaning that x plus y is the one that needs to take the bigger number here. So we have x plus y is equals to 13. Then we also have x minus y is equals to 5. Now this becomes a simultaneous equations in which we have to solve for both x and y. So we have x plus y is equals to 13 as our equation 1. Then x minus y is equals to 5 as our equation 2. So just by making you can just see that we can subtract these two equations. So if we subtract, we eliminate x and we have 2y is equals to 8, meaning that y is equals to 4. Then if y is equals to 4, then means that x minus 4 is equals to 5, meaning that x is equals to 9. But we have to recall what we said here. We said let x is equals to 3 to the power m over 2. meaning that we are going to replace x with 3 to the power m over 2 because we are solving for m. So we are going to have 3 to the power m over 2 is equals to 9 because it's equals to x, is it? So we are going to have 3 to the power m over 2 is equals to 3 to the power 2. 9 is 3 to the power 2. Then here we have the same basis, so we are going to have m over 2 is equals to 2, meaning that the value of m that we have is equal to 4. So we can also try it with the value of y here, which is 4, by saying, recalling that y is equals to 4, and yet y is equals to 2 to the power m over 2. Then you replace 2 to the power m over, you equate 2 to the power m over 2 to 4. So this is the value of m. So we are done with such kind of an Olympiad question. And if you liked our video, please make sure you subscribe to our YouTube channel. More videos are yet to come. Thank you.